Huh? Good afternoon, everybody. Actually, a message was conveyed from our speaker that due to some system problem, he is replacing his system, so not able to join. So we have to wait for 5 minutes more. Please bear with us.
Sir, this program is delayed by how much duration, sir?
Actually, due to a system problem of the speaker, actually something is going on in his system, that is updating or something like that. So he is not able to join. So he is making alternative arrangements. So we hope within 5 minutes that problem will be solved.
Okay, sir. Thank you.
हाँ सर जान करिए ମୁଁ ଏବେ
ହଁ ମୋର ହେଲା ଏବେ ଷ୍ଟାର୍ଟ ହେଲା। ହ୍ୟାଲୋ ହେଲା ନା?
हाँ सर
ଓକେ
ओके
ଏବେ ଶୁଭାଯାଉଛି ସାର୍?
कौन कहली सर
ମୁଁ କହିଲି ଦେଖି କ୍ୟାମେରାଟା ଅନ୍
ठीक है ठीक है
ଏବେ ଠିକ ହେଲା ତ ସାର୍?
हाँ
ଏବେ ଆରମ୍ଭ କରନ୍ତୁ। ମୁଁ ଅଛି ପ୍ରେଜେଣ୍ଟେସନଟା ଇଏ କରିବି। କ୍ୟାମେରାଟା ଅନ୍ କରିବାକୁ ପଡ଼ିବ ଦେଖିବେ। ହଁ ହଁ ନହୁନି କ୍ୟାମେରା ନହୁନି ଖାଲି ଅଡ଼ିଓ ଠିକ ହେଲା ଭାଇ। ନୋଟ୍ କରୁଛୁ କ୍ୟାମେରା ଦେଖିପାରିବେନି ବୋଧେ। ସ୍କ୍ରିନ୍ ସେୟାର ତ କରିପାରିବେ। सर को डायरेक्ट आरंभ कर देबी ना कोन?
ना नहीं सर दउची इंट्रोडक्शन दउची। हेलो
मु के सर मोर कैमरा देखा जाउछ मते देखि परछुंती?
नहीं कैमरा तो जना पड़नी।
देखा जाउनी ना
कैमरा टा काई नउनी मोर ऑफ है फटाफट। परछिंदी हां सर मोर ही कैमरा अब करथला हां आगे मु ऑन करेनी तुम जाने केम फोन करिया
सेटा मागुथो एक्सेस कैमरा एक्सेस बोली सेटा
कैमरा से चेक कर दो
सर आसिफ नाम एक्सेस कर दी
करथिलो एक्सेस तो करिथिलो देखु मागुनी कैमरा नो
शेयर स्क्रीन कर दूं तो
शेयर स्क्रीन के
शेयर स्क्रीन हबो
मोर भी एक्सेस होनी कैमरा से भी कोन प्रॉब्लम अछि बोले ठीक है।
अपन उसे जेतल जॉइन करथो सेतल मागुथबो वेबकैम एक्सेस मागुची आप डिनाय और एक्सेप्ट सेतिर एक्सेप्ट करी अलाउ
से सबले मागे कि देबे मागुनी
ना ना मागु नथला केबे एबे मागुची मु आज देखिली जेतल आपन को मु मागिली जॉइन करिया पई से प्रथमे सेटा मागिवो एक्सेस कैमरा एक्सेस वेबकैम इज आस्किंग फॉर एक्सेस टू योर सिस्टम अलाउ और डिनाय अछि मु जस्ट टेस्ट करथि मु गंजी बिंदी बसची टेस्ट कर
কিন্তু আর ক্যামেরাটা নউনি আমার স্যার।
আচ্ছা শুনুন স্যার
হ্যাঁ
স্যার গোটিଏ ସିଷ୍ଟମରେ ଆପଣ ଜଏନ୍ କରିଛନ୍ତି ଆଉ ଗୋଟେ ଥରେ ଜଏନ୍ କରୁନାହାନ୍ତି ନହେଲେ ଏଇଟା କାଟିକି ଜଏନ୍ କରନ୍ତୁ ଆଉ ଗୋଟେ ଜଏନ୍ କଲେ ଦେଖିବା
ନହେଲେ ଆଉ ଥରେ ସାର୍ କାଟିକି ଜଏନ୍ କରନ୍ତୁ ଆଉ ଥରେ।
ନା ନା ଆପଣ ଦିଟା ସିଷ୍ଟମରେ ବେଳେ ବେଳେ ଜଏନ୍ କରନ୍ତି ସ୍ପିକର ମାନେ ଗୋଟାରେ ଦେଖୁଥାନ୍ତି ଗୋଟାରେ ଇଏ କରନ୍ତି ଆପଣ ଆଉ ଗୋଟେ ସିଷ୍ଟମରେ ଜଏନ୍ କରିକି ସେଠି ଯେତେବେଳେ ମାଗିବେ
ସିଷ୍ଟମରେ ଟିକେ ପ୍ରୋବ୍ଲେମ୍ ଅଛି ସିଷ୍ଟମରେ ପ୍ରୋବ୍ଲେମ୍ ଅଛି
ନା ନା କିଛି ନଥାଏ ଆଉ ଗୋଟେ ଏଥିରେ ଜଏନ୍ କରୁନାହାନ୍ତି ଟିକେ ଆପଣଙ୍କର ତ ସେୟାର କରିପାରିବେ ଏଥିରେ
ଆଉ ଗୋଟେ ସେ କମା ଦିଟା ଲାପଟପ୍ ଗୋଟେ ଲାପଟପରେ ପ୍ରୋବ୍ଲେମ ହେଲା ନା 10 ୱିଣ୍ଡୋ 10 ଟା
ଖରାପ
ଦେଖୁନି
ହେଇଯାଇଛି।
এটা লউনি কোন ପାଇଁ ଜାଣି ଏରର ଦେଖୁନି
ହଁ ମ୍ୟାଡ଼ାମ କୁହନ୍ତୁ।
ଏରରଟା କଣ କରିବା
ମୁଁ ଜଏନ୍ କରିବି ତ
ସାର୍ ଆପଣ ସେୟାରିଂ କିଛି କରିପାରିବେନି ସେ କ୍ୟାମେରା ଏଠି ମୋତେ ଦେଖଉନି
ନା ଆପଣ ସେୟାର କରିପାରିବେ ଆପଣ ସିନା କ୍ୟାମେରାରେ ମାନେ ଆପଣଙ୍କ ଫିଗରଟା ଦେଖେଇବନି କିନ୍ତୁ ସେୟାର କରିବାର କିଛି ଅସୁବିଧା ନାହିଁ ସେ ସ୍କ୍ରିନରେ ଯାହା ସେୟାର କରିବେ ସେଟା ଦେଖେଇବ ଆପଣଙ୍କୁ ଆମେ ଦେଖିପାରିବୁନି
सर आपको के लिए देखा
ହଁ ଏ ୱିଣ୍ଡୋ ଦେଖୁଛି କୋଉଟା କରିବି
एंटर
କୋଉଟା
सर
ଏଇଟା
प्रेजेंटेशन
ସାର୍ ମୋର ଦେଖି ପାରୁଛନ୍ତି କି ଏଟା
ୟେସ୍ ୟେସ୍ ତାକୁ ଫୁଲ୍ ସ୍କ୍ରିନ୍ କରିଦିଅନ୍ତୁ ସାର୍
ହଁ ହଁ
ହଁ ସାର୍ ଏବେ ଠିକ ହେଲା ଏବେ ରିଜଏନ୍ କଲା ପରେ ହେଲା ଏବେ ରିଜଏନ୍ କଲା ପରେ ହେଲା ଠିକ ଅଛି।
ନାଇଁ ରିଜନ୍ ନାହିଁ ସେଇଥିରେ ଅଛନ୍ତି ରିଜନ୍ ତାଙ୍କ କ୍ୟାମେରାଟା ଆସୁନି
ନାଇଁ ମୁଁ ରିଜଏନ୍ କରେଇଲି
ହେଲା କି ସାର୍ ଆରମ୍ଭ କରିବା ଆଉ
ଓକେ ସାର୍।
ଟିକେ 10 ମିନିଟ୍ 15 ମିନିଟ୍
Sorry for the delay, dear participants. Please bear with us. Due to some system problem, the speaker was not able to join. So he has now already joined, and we are going to start our session now. So before that, I want to have a brief introduction of the speaker of this session. So Dr. Sarat Chandra Sahu, he joined in India Meteorological Department as meteorologist grade 2 training through UPSC for 1 year training in weather forecasting and its related subjects. Then after completion of 1 year training in weather forecasting at Pune, he joined as a meteorologist grade 2 at Central Seismological Observatory, Shillong, Meghalaya. He was deputed to United States of Geological Survey, Colorado, USA for training in earthquake sciences and also did his PhD in seismology on the subject crustal structure of northeastern India and its neighborhood from dispersion of seismic surface waves in Guwahati University, Assam. During his posting at Shillong, he was promoted to meteorologist grade 1 and then director in the year 2002. He was instrumental for implementation of modernization scheme of digital earthquake recording in addition to analog recording at Shillong. Under his supervision, GPS meant for study of tectonic movement of Indian subcontinent of Center for Mathematical Modeling and Computer Simulation, Bangalore, was functioning at Shillong. He was transferred from Central Seismological Observatory Shillong to Meteorological Center IMD Bhubaneswar in the year 2004. He was involved in weather forecasting, including warning system for cyclone, Kala Baisakhi, heavy rainfall, and also for aviation services for the state of Odisha at Bhubaneswar. During his posting at Bhubaneswar, he was deputed to Shanghai, China, Dhaka, Bangladesh, and Toulouse, France by Government of India for attending WMO meeting and also training in meteorology. Modernization scheme of IMD from traditional system to digital system of meteorological services, including automatic weather system, were implemented during his tenure at Bhubaneswar. Acquisition of land and construction of buildings there for the installation of a Doppler weather radar at 4 locations in Odisha were supervised by him. Now the Doppler weather radars are operational at Paradip and Gopalpur. State-of-the-art seismological recording at Bhubaneswar, Rayagada, Jharsuguda in Odisha are installed during his period. He was involved in day-to-day weather forecasting and its related warning such as cyclone, heavy rainfall, severe thunderstorm, fog, spatial rainfall as well as its intensity for 9 river catchments, heat wave, etc. for the state of Odisha. So with this brief introduction, I would like to request Dr. Sahu to start his presentation.
Good evening to everybody. Sorry for the delay because this my laptop got problem that Windows 10 started configuring and it was not completed. I called a student and applied that laptop. That's why some problem is there. Also, camera is not working. I could not test earlier. So sorry for the delay. So I will start the topic because they have asked me to give the climate, cyclone and environment. But accordingly, I have prepared the topic role of environment for climate change and mechanism for formation and intensification of tropical cyclone. So environment, we understand that these are my outlines. I will speak introduction, atmosphere layers, role of greenhouse gases, impacts on the environment, physics of formation and intensification of cyclone, impacts on warning systems, weather forecasting practices pre-pro 1999, because 99 there was super cyclone in Odisha, and conclusion. Because we understand that environment means the surrounding around us, because the layer where we are living on just on the surface of the earth, that is called biosphere, which is conducive for the living of human beings and the plant life. So that's why the environment is important for us. If the environment somehow is interfered by the human beings for artificial purposes, then our environment is disturbed. Otherwise, we are okay by the environment, very suitable or conducive for our living, because we have got two radiation. One is coming from sun, that is short wavelength radiation, and another radiation transmitted by the earth also, that is called terrestrial radiation. Both radiation are balanced. If the balance, then we will not have any problem in the environment. If there is any discrepancy, then we will have problem. That we will discuss in later slides. So living things do not simply exist, because we are living in the environment, but not simply existing, because we are interacting with it. So our interacting means that means interaction between plants, animals, soil. That's why every creature or everything they have interaction among them, so that the human beings and other animals and plants' lives. So we have existed and we are also surviving in this environment. So how the environment? Because I told you that we are getting we have two radiations. One is coming from the sun. It is a short wavelength radiation. Another radiation is transmitted by the earth. That is called terrestrial long wave radiation. So the radiation coming from the sun, that is the incoming solar radiation, is balanced by the outgoing terrestrial radiation. If the balance is in somehow in case it is disturbed, then we will have problem. The problem which we are now facing due to the imbalancing of radiation, outgoing terrestrial radiation and incoming solar radiation. So if you see the radiation balancing, because we are getting the heat on the surface of the earth by two processes. One is from the sun, that is 161 watt per meter square. Another from the greenhouse gases, that we are getting 333 watt per meter square. If we add 333 plus 161, it is called 494 watt per meter square, and that 494 watt per meter square also retransmitted or re-radiated to the upper atmosphere. That will be 396 by surface radiation, 80 by evapotranspiration, 17 by other thermals. So around, if you add it, total will be 393.1. Only 0.9 earth is observing. So if this balance is maintained, then we will not have any problem, any seasonal variation, and will not have any climate change problem, and it will be very conducive for the survival of the living things, that means human beings, animals and plant life. And but this radiation imbalancing is there, then we have problem. And this is how it is being imbalanced, that I will go on speaking some few next slides. So these major environmental issues, we have pollution of air, water and land, hazardous chemicals and waste, land degradation, loss of biodiversity, ozone depletion, climate change, loss of natural and cultural resources. These are the problems in the environment. So if you see, these are the gases present: nitrogen, oxygen, water, argon, carbon dioxide, neon, helium, methane, hydrogen, nitrous oxide, oxygen. All the gases, these are the constituents of the atmosphere or the environment. But some of the gases, we call it greenhouse gases, like water, carbon dioxide, methane, nitrous oxide, ozone. These are greenhouse gases because their properties are like that. they do not absorb solar radiation, because short wavelength radiation is solar radiation. It has maximum intensity at 0.5 micron, whereas the Earth has maximum intensity at 10 micron. So Earth has called that is long wave radiation, and the sun radiation is called short wavelength radiation. These particles, these greenhouse gases, why we call greenhouse gases? Because these greenhouse gases, they are transparent with solar radiation, but they are the good absorbers of terrestrial radiation. When they are absorbing the terrestrial radiation, they are also re-radiating as per the property. If you say good absorber is a good radiator, like we have been studied in physics, Kirchhoff's law, it says that good absorber is a good radiator. When they are absorbing it, they will also re-radiate it. When they re-radiate it, again it will come back to the Earth surface. And the Earth surface already getting the heat by the natural process. And if the additional heat they are getting by re-radiation of the greenhouse gases, it causes problem. So, and our atmospheric layer, our atmosphere, you see, we have 4 layers. The lower part of the atmosphere is called troposphere, because here we have the temperature decreases with height, because troposphere's height it varies from equatorial region to polar region. Equatorial region it has more height, maybe 18 kilometer, 14 kilometer, 15 kilometer. But polar region is less height, because the higher temperature area, the troposphere height is higher. Cooler temperature area, troposphere height is lower. The troposphere height means that's a constant temperature layer in between troposphere and stratosphere. Again, stratosphere when it comes, so stratosphere, the ozone layer is present. Ozone property like that, because the radiation which we are getting from the sun, it has 3 branches. One is called ultraviolet, another is visible portion, and infrared. The radiation less than 0.4 micron, we call it ultraviolet radiation. The radiation in between 0.4 micron to 0.7 micron, these are called visible radiation. And the radiation more than 0.7 micron, this is called infrared. Infrared radiation, these are heat waves. And the ultraviolet radiation, this is like X-rays, is very harmful. And these harmful radiations are absorbed by the ozone layer. So in the stratosphere, in troposphere, the temperature decreases with height. Due to presence of ozone layer, the temperature increases with height in the stratosphere. Again, you come to mesosphere, mesosphere temperature decreases with height. If you go to ionosphere, because closer to the sun, so again temperature increases with height. Because in troposphere and ionosphere, the temperature increases with height. In troposphere and mesosphere, temperature decreases with height. So these are required for the climate, because weather and climate both are different. Weather means the day-to-day particular instant of time and a particular place, we are recording the meteorological parameters like temperature, pressure, humidity, rainfall, wind direction, wind speed. We call it weather, and it varies from particular time to another time. Because in the morning when you get up and that whatever the weather we experience, at 10 o'clock weather changes, and 1 p.m. weather changes, 5 p.m. weather changes, night also weather changes. Time to varies. But if you integrate, or if you take the average of 30 years data of weather, then we get the what we call the climate. The climate is the static parameter. That means because if you see the 22nd February, today might be it is a sunny day, but it's similar may not be in 2021, 20 or 19 like that. If you add like that way, so we will get the average weather of 22nd date of Odisha region. But it will have the average idea, but it may not be exactly varying, but the variation will be very minimum. That's why the climate, we call it a static parameter. This is a 30 years average data of weather parameters recorded every day. So, and this climate is static, we are telling, but the climate is changing, because when into 1980 or pre-industrial, whatever the climate we are experiencing, now the climate is quite different. So how it is that? Because climate is different. I told you that the climate is changing. The main responsible is the greenhouse gases. How it is there? Because natural wells also climate is changing, and human factors of artificial. That means climate change occurs by 2 processes. One is by natural process, another by artificial process or human interference process. That human factors are there, these are called artificial, and natural factors are these. What are the natural factors? These are solar variability, volcanic dust levels, internal variability, geologic change. Solar variability, what we understand, that means the radiation coming from the sun is a constant, but it is not actually constant in 1980, because now we have got satellites. Solar emitters are fitted in satellites. The measurements have been taken in 1980. So there is, for our 18 months, they have found that there is 0.1% decrease in solar radiation. But the model says that if 1% decrease solar radiation, there will be variation of temperature 0.5 to 1 degree Celsius in the globally. So this is a solar radiation, but solar radiation, it is falling on the surface of the earth or top of the atmosphere. It is controlled by Milankovitch theory. There are three factors. One is called eccentricity, second is called precision of equinox, third is called obliquity. Eccentricity means while Earth revolving around the sun, so it is not a fixed path. It changes its orbit from elliptical to circular and circular to again elliptical, and that cycle elliptical to circular and circular to again elliptical, this is 1 lakh years. So that's why we have the difference in timing, perihelion and aphelion. Perihelion is January, aphelion July. So perihelion means that is we have a shorter day period, and aphelion means that is a longer day period. So January and July variation is there. So they are telling when we are nearer to the sun, that is the perihelion, and our distance from the sun, that is aphelion. So this is 3% variation in distance, whereas that energy variation is 7%. They are telling if it is 3%, 9%, energy variation will be 21%. So you can imagine how much changes will be there. So this eccentricity also plays the role, but this cycle is 1 lakh years. Gradually it will change. So we have when we are living in this planet, or when living on any location, so gradually we will be experiencing the changes. So we may not feel it immediately. So that's why it has no effect, but a gradual change. But the climate is changing due to this process. Another is called precession of equinox. That precession of equinox means that Earth is rotating on this polar axis. While rotating, it wobbles like a spinning top, changing our equinox and solstices. So that is called precession of equinox. That means we are now having perihelion in January and aphelion in July. That means they are saying this cycle is 26,000 years. Perihelion to aphelion and aphelion to perihelion, 26,000. After 13,000 years, it will be changed. That means January will be aphelion, that means farthest from the sun, and July will be nearest to the sun, that will be perihelion. So these 13,000 cycles, so automatically we'll have changes in the climate and all these patterns, because the sun is the source of energy. And when the sun's energy varies according to the distance, or when will it nearer to the sun, whatever the climate will experience, when will it farther from the sun, the climate will change. So this is also one of the process, but the cycle is 26,000 years. It is slow process. Another is called obliquity. Obliquity means while rotating on its axis, Earth is not perpendicular, it is tilting. That tilting now is 23.5 degree. They say that it varies from 22.5 to 24.5 degree. So when it is lower minimum, the climate variation is very minimum. When it is higher tilting, the climate variation will be higher. That's why now we have got winter. Winter is not too much cold, and summer also not that means pinching hot. So that means summer or winter also little warming is there. When little warming is there, that atmosphere can hold moisture. When atmosphere can hold moisture or water vapor, then probability of formation of glaciers or snow or ice on the deposition on the mountain ranges or glaciers there. And during the summer period, when we will have the dry period and heating, so our river beds will be what we call dry. So that's why our this Ganga, Sindhu, Brahmaputra, they are called perennial rivers. Perennial means they are getting water by rain in the monsoon period, and in dry season summer period due to melting of glaciers we are getting. But this is a routine process, and if after 13,000 they are telling this cycle will be changed. When it is changed, the winter will be more bitter cold and summer will be too much hot. So when bitter cold, the glacier formation will be minimum, and whatever the glaciers are formed, most of the glaciers might be melted during the summer period. So we'll have a very great change in the climate that anticipating after 13,000 years. So this is called solar variability. So solar variability, another is also solar variability, that is called your sunspot theory. Sunspot theory also, the cycle is 11 years, 90 years, 180 years. That means when more sunspots means magnetic activity strong, when lower sunspots means less sunspot means magnetic activity low, less. They also support the radiation coming from the sun, falling on the surface of the earth or top of the atmosphere. It will, when that sun's energy is varying, automatically there will be change in the climate, in the surface also, in the atmosphere. This is called solar variability. Another is called volcanic dust levels. Volcanic dust levels means during volcanic volcanic eruption, so a lot of materials like gases, some of the acids, or waters, or so many things, or hot materials may be ejected to the upper atmosphere. So they will be like sulfur dioxide, nitrous oxide, so many things will be ejected to the upper atmosphere. Sulfur dioxide reacts with the water vapor, they will form sulfuric acid. Nitrous oxide reacts with the water vapor, forming nitric acid. So they will form a hazy layer. 7-8 years back, there was a problem in European countries. So due to volcanic eruption, so most of the flights were cancelled because the visibility was poor, less than 1,000 meter or 1,200 meter. When visibility less than 1,200 meter, some of the flights may not be permitted to fly or take off or landing. So that was a problem because haze layer will form. So that haze layer, because when sun rays are coming, it cannot penetrate the head layer falling on the surface of Earth. So temperature will decrease. So, but it is a temporary case. It is not permanent because it happens due to volcanic eruption. So another is called internal variability. Internal variability, understand that is El Nino and La Nina. Because now the La Nina is going on, because El Nino is a factor that is a abnormal rise of sea surface temperature in the Peru coast, in the South America, that is equatorial South America regions, Peru coast. It happens like that because whatever the sea surface temperature, it increases about 0.5 degrees Celsius. That's why it is called El Nino. So they say that El Nino also 3 types: weak El Nino, moderate El Nino, strong El Nino. When the temperature is 0.5 to 1 degree Celsius variation from the normal sea surface temperature, they call it weak El Nino. When it is 1.0 degree to 1.5 degrees Celsius from the normal sea surface temperature, they call it moderate El Nino. When it is more than 1.5 degrees Celsius, they call it strong El Nino. That strong El Nino happened in our Indian subcontinent in 2015. So we had a bad monsoon in 2015 because El Nino disrupts the monsoon current. When the monsoon current disrupts, because the monsoon we get in our Indian subcontinent, it not only from Arabian Sea, Bay of Bengal, Indian Ocean, it comes from Pacific Ocean also, Atlantic Ocean side, that side also. Large, because at that time Indian subcontinent is hot and low pressure belts are formed here, and those areas are high pressure belt called La Nina areas. So automatically wind flow from Pacific Ocean and that South China Sea, then Bay of Bengal, then it comes to Indian subcontinent. So we get plenty of rain, spell wise rain in the morning, in the forenoon, afternoon, and night, like that. It goes on when the morning. But nowadays, when there is one spell of rain, then next 3-4 days there is no rain because water vapor is exhausted. But at that, during the monsoon period, due to continuous flow of water vapor over the oceans, so when there is the rain in the morning, so it may be exhausted water vapor. Again, it is filled up, refilled by the ocean current. So again, we are getting rain at 10 o'clock, then 1 p.m. evening, night, like that continues. But similar things do not happen in other season except monsoon. When La Nina is there, high pressure will be there in the South European countries, South American side, in the equatorial region. So over Pacific Ocean, there will be high pressure. The wind will blow from Pacific Ocean, then South China Sea, then Bay of Bengal, then Indian subcontinent, we get rain. While El Nino will be there, so instead of a high pressure, it will have a low pressure because temperature will be higher. When temperature is high, the pressure will be low. So whatever at that time wind we are getting from east to west, now the wind will reverse. It will go from west to east. So all the water vapors from South China Sea and Indian Ocean will flow towards South America side, that is equatorial region. So we'll have less water vapor available for the Indian subcontinent during monsoon period. So El Nino has also problem. So that is called internal variability. Due to that also climate, because when there is a rainfall variability will be there, automatically climate will change. When there is no rain, so automatically temperature will increase 33, 35, 36 degrees Celsius during monsoon, which should not happen like that. In general, monsoon side period, the temperature may be around 20, 32, 31, like that it happens. If it's 35 and above, that is abnormal temperature. If El Nino condition like that, so we'll have clouding will be there, but no rain. There is no any supporting phenomena which can support the rise of water vapor from surface to upper atmosphere. If water vapor doesn't rise from surface to upper atmosphere, then we cannot anticipate the cloud causing the rain. So this is the problem, internal variability. Another is the geological change. Geological change, this is a plate tectonic theory. So they say that some millions ago, 71 million ago, Indian subcontinent was in the southern hemisphere. When we are in the southern hemisphere, so whatever the climate, because southern hemisphere it is full of ocean and water bodies. So whatever the climate we can experience, when it will go upper part of towards the equator, then towards north, the climate will be changing. So the whole world, that means it is divided into number of plates, because earlier it was joined by the Gondwana Island. So due to some physical chemical process, it is segregated or separated, and depending upon their physical and chemical properties, so different plates are forming, and the plates are also moving. In our Indian subcontinent, it is moving 5 centimeter every year towards northeast. That means if today's date, if you measure the latitude longitude by your mobile and the 22nd February 2022, and if you measure 22nd February 2023, you will find the change, and the difference will be around 5 centimeter, because some of the computer programs they have developed, because so many GPS, the government of India and government of China, that means WMO, World Meteorological Organization, they have installed in different parts here. Our this Tibetan region also, Lhasa, Phasa, in our India also, Bangalore, Shillong, all this Impal, so many places in Northeast India, because North India prone to major earthquakes, so they have installed there. So by that measurement also, they have got, applying the computer measurement, they have got also around 5 centimeter of movement towards northeast. That's why when we are in the equatorial belt, so whatever the climate we are experiencing, when we are going towards extratropical countries or higher latitudes, the climate will be changing. This is also one of the factors. So the climate is changing. That's why we say that geological change, these are the natural factors which cause the change in the climate. But these are slow processes, what I told you, very slow processes. And it's not that like El Nino, it doesn't come every year, but that forecast also not possible which year it will come. Last 3 years we are experiencing La Nina conditions, and this year also it is predicted that up to July, so La Nina condition will persist. Thereafter it may change, I do not know, because computer models will indicate. So human factors, these are called greenhouse gases, aerosols, ozone depletion, land use changes. These are the factors which cause the change in climate very acute and immediate. Then we'll discuss all those things. Greenhouse gases, mainly we have water vapor, carbon dioxide, methane, nitrous oxide, tropospheric ozone, like that. I told you they have the property like that. They absorb only solar, terrestrial radiation, that is long wave radiation. There are
sir, one question, sir.
Radiation. Hello?
Sir, one question. Sir, you told that due to La Nino and El Nino,
yes, sir.
Our climatic changes takes place.
Yes,
actually,
sir.
what causes La Nino and El Nino?
La Nina, that I told you that sea surface temperature over a equatorial region, central equatorial region of Peru coast in South America.
That again is due to our climatic condition.
Yeah, because you see, during the monsoon period, our Indian subcontinent is too hot. So when hot is there, low pressure will be formed in Indian subcontinent, like Odisha, West Bengal border, or Odisha, Andhra Pradesh border. Generally, low pressures are forming. When low pressures forming, its property that air mass will be very less. So as per atmospheric process, there will be balance between higher mass and lower mass. So higher mass on the high pressure side. So our Pacific Ocean, that I told you that Peru coast, this is a Pacific Ocean side. So the high pressure will be there. So wind blow from that side to Indian subcontinent during monsoon period also, when during La Nina period. When El Nino will be there, those areas will have higher temperature. When higher temperature means, though it is 0.51 degree, but in the atmosphere also it causes changes. So due to that El Nino condition, so low pressure will be there. When a low pressure that side, automatically earlier wind was coming from east to west towards Indian subcontinent. Now wind will blow from west to east. That means the South China Sea and from Indian Ocean, wind will blow towards that side, our Peru coast or Pacific Ocean side. So automatically water vapor flow towards Indian subcontinent will be minimized. This is the reason, sir.
Okay.
Okay, sir.
Okay, sir. So that means El Nino and La Nino are cyclic in order.
Not cyclic, because El Nino it doesn't come every year. Last 3 years we don't have El Nino. Only 2015 we had El Nino. Thereafter El Nino also again 2018 or 19 there was El Nino. But last 3 years we didn't experience El Nino.
Okay.
Now La Nina condition is going on, but they are telling that up to July La Nina condition will persist. So then when La Nina condition persists, we can anticipate very good weather.
Okay, sir. Okay, sir.
So these are the greenhouse gases, I told you. Greenhouse gases, why they are called? Because they are transparent to the solar radiation and they are good absorbers of terrestrial radiation. So when they are absorbing terrestrial radiation, they are radiating it. When they are radiating, again it is coming to the earth. So temperature rising. How they are functioning, I will tell you, because they have the selective absorbers, because the radiation coming from the sun or released by the earth are not absorbed fully by the constituents present in the atmosphere. Like ozone, they absorb in between 0.2 to 0.3 micron. That is called ultraviolet portion of the radiation. Again, 9.6 micron, that is the infrared portion of the radiation. Whereas the water vapor less than not water, but that oxygen, less than 0.2 micron. Water vapor absorbs the radiation. Water vapor absorbs the terrestrial radiation. That is the radiation transmitted by the earth. That 1 to 8 microns, again 12 microns. So carbon dioxide absorbs in between 13 to 17 microns, because these are long wavelength band. So long wavelength band, these are called infrared portion. These are the heat energy. That's why when water vapor is more in the atmosphere, we can feel heat or uncomfortable weather. Like December to February, but exceptionally this year, because generally in other years we do not experience the influence of western disturbance. But this year the frequency of western disturbance is very high, 4 to 5 numbers. It has occurred in western India also, and it is moving towards Odisha. Generally it do not come. It comes to the Bihar and UP latitude, but it is coming in the lower latitude around 20 degree, 25 degree. So it is affecting our Odisha. That's why this year we are having a atmosphere water vapor. That's why only in the December we had 3 days very cold. Thereafter the cold condition is not prevailing in Odisha due to that western disturbance. So my point is that water vapor, they are called greenhouse gases. When presence of water vapor is high in the atmosphere, automatically the temperature will rise. So, and the carbon dioxide also 13 to 17 micron, when their concentration is high in the atmosphere, they will also cause the heating process. So they have got, but 8 to 11 microns, that we call it atmospheric window. So that now we are able to get the TV news or TV function or mobile use 24 hours, because by nature 8 to 11 microns is vacant. So no gases particularly absorbing or radiating by that that band 8 to 11 micron. So that's why the electromagnetic rays, they can go to the upper atmosphere, ionosphere, and again return back to the lower atmosphere. That's why we are getting TV service and mobile service 24 hours whole the year like that, due to that. Because my point is that ozone, oxygen, water vapor, carbon dioxide, they have got the specific bandwidth. They absorb the radiation coming from the sun and released by the earth also. So there are global trends. These are the gases. So now the problem is that the greenhouse effect. Greenhouse effect, they form like a greenhouse. Greenhouse effect means that is a glass house, like in our southern India, Bangalore, like that. They also cultivate tomato, all this they produce during winter period, also in summer periods. They adjust the temperature because they develop the green glass houses. Because solar radiation, there are the short wavelength radiation through the glass, it can penetrate inside, and but the long wave radiation cannot go through the glass. So they maintain the temperature. So similarly in the atmosphere, these greenhouse gases, they support the greenhouse effect. That's why we are having the temperature is neither high nor low. So that's why this is conducive for the survival of the mankind or plant life. But when that greenhouse effect functioning is a higher side temperature, then it becomes uncomfortable, but that is called climate change. So these are the major sources of greenhouse: natural causes, energy production, industry, transport, land use and animal husbandry, domestic sources. These are the causes. And the carbon dioxide concentration also increasing. You can see these are the increasing. And here also carbon dioxide, how increasing you can see. These are the industrial area started, because from 1987, 88 like that, the sharp increase is there. So who are the countries is responsible for emission of the carbon? These are United States, China, Europe, Russia, India, Japan. If you see United States, the highest, China, then Europe, then Russian country, then India, then Japan. But recently it has been changed. If you see the recent data, 2017, China is the largest emitter of carbon dioxide compared to United States, then India third, then Russian Federation, then Japan. This is 2017 data. So that ozone comes. I told you ozone is created or destroyed by natural processes in the upper atmosphere, and its concentration is high, around 25 kilometer height from the surface of the earth. That is called stratosphere. That's why in the stratosphere the temperature increases with the height. So due to presence of ozone, ozone is created, that is atomic oxygen and molecular oxygen both combined, they form the ozone, O3. So but dissociation also in presence of ultraviolet radiation, it dissociates. So the formation and dissociation balance. So we do not have a problem. And ozone, when present in the upper atmosphere, it absorbs the ultraviolet, which is very harmful for the human. It causes skin cancer, eye blindness, and also retards the crop growth. When crop growth is retarded, then crop production will be decreased. So that's why ozone layer, it absorbs ultraviolet radiation. So it was not, but the ozone layer being what you call damaged or depleted. So how it happened? Because the formation and dissociation is a natural process, and it is a slow process and continuing balancing way. But this is chlorofluorocarbons, chlorine, fluorine, bromine, iodine groups. These are called cooling reagents. So now only we have started using air conditioners and refrigerators in our developing countries. But developed countries, long back, they have taken the advantage, or they have enjoyed using the refrigerator or air conditioners. So many this is the liquid profiles. So by that way, this chlorine, bromine, the earlier chlorofluorocarbon was used, CFC was used. So those who have gone to the stratosphere, so when the dissociation normal process, they have acted as catalyst. This chlorofluorocarbon, they have acted as catalyst, and dissociation is high. Whatever the formation is there, dissociation high. So ozone became less, or ozone layer or ozone hole is created. That's why it's called depletion of ozone in the stratosphere due to presence of fluoro. Now also it's changed. Now the CFC is not being used in our air conditioners or refrigerator also. Some other reagent used which has no effect to the climate. So this is O2 and O like that. This is formula.
Excuse me, sir. Sorry for short intervention. Hello.
Police, sir.
Actually, there is a attendance link for the participants. They can mark it within 10 minutes.
Attendance.
Attendance link. Okay. So, but now you can continue.
No. It is 6 to 7:30, na?
No. Attendance link. Attendance link for the participants. They have to give their attendance.
Okay, they can do.
Okay.
So while they're doing the link to the attendance, I can speak or not, sir?
Okay, sir. No problem. You can continue.
Okay. So that ozone, if the ultraviolet radiation come to the surface of Earth, you see human health has problem. It can cause cancer, cataracts, impaired immune systems, also crops, ecosystem, biogeochemical cycles, air quality, plastic. These will have the problems. So then similarly aerosol also. Aerosol means that it is organic carbon, black carbon, nitrogen aerosols. If black aerosols are there, it will absorb solar radiation. If white aerosols are there, they will reflect the solar radiation. So because main cause is the solar radiation. Because when it is more absorbed, then we cause heat. When it is reflected back, so automatically we will feel cool. So land with land change. In 1983, it was covered by the vegetation. When vegetation is there, what will happen? The solar radiation during photosynthesis, evaporation will be there. Evaporation causes cooling. So temperature will not high that much up. If we see 1883, 1921 and 2000, gradually denuding or depleting or reducing the greeneries or vegetation. So when greenery is reduced or vegetation is removed, so automatically whatever the radiation coming, mostly it will be reflected back. The albedo percentage will be high. When albedo percentage is high, atmosphere will be hot. So automatically temperature will increase. So these are also causes. These are called man-made causes cause the temperature. These are called climate change and environment, how it is interfering and causing hazards to the human life or plant life. So greenhouse gas is essential for us. Without greenhouse gas, we cannot survive. You see, if you see the first picture, without greenhouse gases, the temperature will be reduced to minus 18 degrees Celsius. But minus 18 degrees Celsius, we cannot survive. Because if in presence of greenhouse gases, in the tropical region and polar region, the temperature is 15 degrees Celsius. So what will happen? It is conducive for the human being living 15 degrees Celsius. But during summer period also it varies around 28, 29 degree. In the winter period, 15 degree. But it changes. So, but if you take the average of polar region and equatorial region, so automatically it is conducive for the human living. But when artificially you remove, it is not possible. It is a hypothesis. So if greenhouse gases are removed, temperature minus 18. So in presence of greenhouse gases, we can survive, but it should be balanced. So, but due to presence of this greenhouse gases, constituent excess, so we are facing the problem. So if you see carbon dioxide, once it has gone to the upper atmosphere, it can survive for 120 years, and global warming potential 1. Methane, global warming potential 11. Non-nitrous oxide, global warming potential 290. Chlorofluorocarbon 5000. That means methane is more harmful than carbon. But carbon dioxide is released to the atmosphere by many processes, by industry, by NTPC or thermal electricity process, by vehicular exhaust, so many processes going. So its concentration is higher, though its global potential is 1, but its constituents are high. That's why it's causing heat. But methane is by some like what you call rooming process of the cattle or these domestic animals, and paddy cultivation also methane is released. Some of the, and this garbage also methane is released. Few processes, but it's global 1% high. So that's why we have to minimize the release of greenhouse gases. That is the main property to make the climate comfortable for the survival of the future generation. So dinosaurs also, they are telling also, so like that, so many. So this is one example. You see globally temperature 14 degree, 15 degree. The S means is sun, L means a long wave radiation by earth. So 240 watt per meter square coming, 240 meter square going. So there is a balance between incoming, outgoing. So earth is comfortable. But here you see carbon dioxide concentration 2 times increase. But 240 watt per meter square is coming, it is constant. But terrestrial radiation released to the upper atmosphere, it is blocked by 4 units. But atmosphere needs balance. Get it balance? Here, temperature 1.2 degrees Celsius. Temperature 1.2 degrees Celsius, we call it global warming. The impact of greenhouse gases, increase of extreme weather events, ecosystem like severe thunderstorm, high intensity cyclone, erratic monsoon circulation, dense fog frequency, heat wave frequency, ecosystem air pollution, health hazards, bronchitis, eye blindness, agriculture, so retardation of crop growth and also reduced crop production, biodiversity, extinct of some plant and animal species, uncompatible to living things, water resources, decrease in groundwater level, increase in sea level. These are the impact of greenhouse gases. So now I'll come to the cyclone. This is a disaster because there are so many disasters: cyclone, thunderstorm, heat wave, your lightning. These are earthquake also, but earthquake is a geological phenomena, but we are discussing only meteorological things or atmospheric parameters. So they said that these things will come because natural hazards, it will come. We cannot stop it because the cyclone coming, it will hit. But we cannot check the cyclone, or we cannot what we call weaken the cyclone. It's very difficult. And though American government tried 2-3 times, but internationally it is not permissible. So and it's also very difficult, and it will change the climate system. Also already the climate change is there. If we interfere again to the natural phenomena, so another climate change problem will be there. Human beings may be extinct, may not survive. So it is not permissible by WMO or international agencies. So they are telling that we have to survive. So survive means in this climate change scenario we have to survive, but we have to adopt some of the things so that our day-to-day living or our future generation can survive in this environment. So there are 2 types of disaster. One is the natural disaster, another is the man-made disaster. These are natural tropical cyclone, flood, heat wave, thunderstorm and lightning, tidal wave, cold wave, tsunami, earthquake, landslides. And these are man-made disasters: nuclear explosion, gas leakage, failure of storage dam, terrorist attack, accidents. These are called man-made. So our Odisha, mainly coastal districts, are prone to different types of hazards: thunderstorm, lightning also, flood also, cyclone also, earthquake also. In India's vulnerability to sea disaster, 57% land is vulnerable to earthquakes. Of this, 12% is vulnerable to severe earthquakes. 68% land is vulnerable to drought. 12% land is vulnerable to floods. 8% land is vulnerable to cyclones. Apart from natural disasters, some cities in India are also vulnerable to chemical and natural disasters and man-made disasters. So now I'll come to cyclone, because a low pressure weather system in which central core is warmer than the surrounding atmosphere. For this reason, they are classified as warm core systems. They are also called hurricanes, typhoons, tropical cyclones, because cyclones have different names in different seas. How it is like that? You see, in the Western Pacific, they call typhoons. In Australia, it is called Willies. Mexico, it is called Catanzo. Philippines, it is called Bagus. Indian seas, we call it cyclone. Indian seas means that is Arabian Sea and Bay of Bengal. Atlantic and Eastern Pacific called hurricanes. These are called cyclones. But in cyclones, the temperature in the central portion, that is called high portion, increases with height. That's why in the high portion, it is a clear sky condition. Though cyclone speed is more than 250 km, but the high region, it is calm. So if you see the northern hemisphere, cyclones, the wind blows anti-clockwise, but in anticyclones, wind blows clockwise. But it is reversed in southern hemisphere, wind blows clockwise in the cyclone system, and wind blows anti-clockwise in the high pressure system. It is on this basis I will explain my topics, that how the cyclone is forming and how it is moving and how it is intensifying. So this is also, you see, cyclone, that means pressure is low inside 968, 976, 984, 992, 1000. These are called isobars, the circular isobars. The pressure at the center is very low. Gradually the pressure increasing outer side. So this is case of a cyclone. So that I told you, when a low pressure is there means the air mass will be less. When air mass is there, surrounding the low pressure area, high pressure will be there. So air mass will be higher that side. So as per the property of the atmosphere, because the atmosphere needs balance, the air mass where is higher, it will try to come to the air mass where is low. So when it is coming from a high air mass to the low air mass, it will come at a high speed. That's why you call it the wind speed. That wind speed increases depending upon the intensity of the low pressure at the center of the location. So it is also classified like in different variation in pressure, like a low pressure area, depression, deep depression, cyclone, severe cyclone storm, very severe cyclone storm, extremely severe cyclone storm, super cyclone storm. So according to pressure deficit, from the normal pressure 2 and depression 2.1 to 3.1, and deep depression 3.2 to 4.5, cyclone 6.1 to 10.0, severe cyclone storm less than 15.0, very severe time 29.9 to 29.4, like that. Super cyclone also it is like that. So if you see the wind speed, this is in bracket is the kilometer per hour. 31 kilometer per hour we call it low pressure, 31 to 49 kilometer per hour called depression, and 50 to 61 kilometer per hour called deep depression, 60 to 88 kilometer per hour called cyclone, and 89 to 117 kilometer per hour it is called severe cyclone, 118 to 166 kilometer per hour we call it a very severe cyclone storm, 167 to 221 kilometer it is called extremely severe cyclone storm, and more than 222 kilometer it is called super cyclone. According to this criteria, whenever any low pressure forms, according to its intensification, IMD says it is depression, deep depression, cyclone, severe cyclone, very severe cyclone, extremely severe cyclone, super cyclone. They categorize. It pressure also falls, and when pressure falls, wind speed increases.
So this pressure in HPA means how to measure?
Hectopascal. Oh, hectopascal and millibar both are same.
Okay, sir. Thank you.
Cyclone are two seasons generally, but now also some discrepancy there due to climate change. In general, we experience cyclone April, May, and up to 15th of June. That is a till onset of monsoon. Another, this is called pre-monsoon cyclone or pre-monsoon season cyclone. Another comes in the post-monsoon cyclone. That is in the month of October, and for our Odisha up to first week of November. But October to December, that is for Bay of Bengal and Arabian Sea. This is the post-monsoon cyclone season. From November second week onwards up to December, in general, if any system forms or cyclone forms, it hits either southern India, that is called Tamil Nadu, South Andhra Pradesh, or western coast side. But western coast having very few numbers of cyclones compared to Bay of Bengal. More number of cyclones are formed in Bay of Bengal compared to Arabian Sea. So this forecasting of cyclone, if you see, we follow many processes. Due to improvement in ecology, IMD provided cyclone into the probable area of crossing the coast before 5 days. But initially, when the low pressure forms and by cyclone, it is far away from the coast. So IMD will say the craze from Gopalpur to you can say Baleshwar. So when it come closer, it will change its forecasting Gopalpur to Puri. Then it will say to it will change Visakhapatnam to Gopalpur, or it will cross near to Gopalpur, like that. When it will come to the closer to the cyclone, because our Doppler radars track up to 250 kilometer at distance. Though 500 kilometers we can see the cloud picture, but the cyclone, that center, all these things are visible up to 250 kilometers from the Doppler radar stations. So we have got 5 Doppler radars. Here Chennai, Machilipatnam. Here we have got Gopalpur, Paradip, then Calcutta. So when Odisha coast it comes, Visakhapatnam Doppler radar also tracks, Gopalpur, Rapala also tracks. Then our Paradip also and Calcutta also, depending upon distance. So when it comes in 250 kilometer range, so then IMD can give the wind speed forecast also, and actual point of crossing, very close to the point of crossing, they can predict. So that's why initially they give the longer range, gradually they change it. So IMD includes cyclones in the daily routine for observation besides special bulletins. IMD issues the cyclone bulletin, special bulletins also every 3 hours. But we have got 4, that is the routine meteorological forecast. So the 4 meteorological, besides 4 observational system, so IMD also issues special bulletins for cyclone. IMD issues special bulletins to modification even about track, intensity and time, as well as area crossing the coast. IMD provides impact-based warning system, because with cyclone coming, what are the impacts? Whether the thatched houses will be damaged, or uprooting of trees, electric poles, telephone cables, like that, something they will give. IMD gives a 3-hourly cyclone bulletin till the system is weakened. IMD provides an hourly bulletin. But when before 12 hours of crossing the coast, with the help of Doppler radar track, so they are giving the hourly bulletin about the location, wind speed, and time of crossing the coast. IMD also discuss with Chief Secretary and Special Lieutenant time to time about the cyclone update. So these are the facilities to forecast the cyclone using satellite imageries, surface and upper air weather charts, radar data from Doppler radar, cyclone detection radar, numerical weather prediction, products from lower level vorticity, upper level divergence and wind shear. That means if air is coming inside, so there should be some mechanism in the upper atmosphere 12 kilometer height, so the air should be removed from there. Otherwise, when air is coming one central location, it will be filled up. So filled up means the air mass will be increasing. So air mass increases means pressure will increase. Pressure increase, cyclone will be weakened. Sometimes also IMD says that cyclone has weakened, though it has intensified to the very severe cyclone in the Bay of Bengal, Central Bay, or some of the distance from the coast. But gradually, sometimes they say that cyclone is weakened because it gets filled up due to air mass, increase in air mass. So wind shear also, that is difference in wind speed, that I'll discuss next. And model-based past record, we have got data, so for around 100 years data. So when the cyclone, about the location of formation, if that location cyclone is forming, in which direction it will go and which area likely to affect. So this is also gives the idea about the location of crossing the coast. So what are the conditions favorable? North latitude of 5 degree north, because 5 degree north from equator, within 5 degree generally low pressures do not intensify to cyclone, because within 5, because for cyclone formation, one Coriolis force is required. Coriolis force is a sort of force that is automatically is generated by the rotation of the earth, and it is the formula is 2 omega sine phi. Phi the latitude. So when 0 degree and the equator is there, sine 0 0. So within 5 degree, this Coriolis force is very minimum or negligible. That's why, because when the wind moves in anti-clockwise, it provides the rotation, increase the rotation speed. So that's why the air mass goes to rise to the upper atmosphere, then cyclone intensification occurs. Otherwise, within 5 degree, cyclones do not form due to Coriolis force. Small vertical wind shear, because cyclone is getting energy from the latent heat. When the water sea surface temperature is around 26.5 degrees Celsius or more, it will have evaporation. When evaporation will be there, so automatically that evaporation supports the condensation. When condensation occurs, that latent heat will release. That latent heat supports continuous heating. Otherwise, once the cyclone form, high wind speed there, churning of wind, churning of the water in the sea, down water will come up water will down. So cyclone will weaken, but never weakens, because that latent heat provides heat. So continuous heating in the sea surface. So the temperature will maintain or temperature will increase. Nowadays, whatever the cyclones are forming, the temperature is around 30 degree, 31 degree due to latent heat increase. So latent heat is support. And when the latent heat is available in a small area, then the cyclone can intensify. If the latent heat is distributed in larger area, the cyclone will weaken. So that's why wind speed should be minimum in the latent heat area. That's why the wind speed at 1.5 kilometer and 12 kilometer height should be very minimum. that difference of wind speed should be very minimum. Otherwise, if wind speed is higher, then whatever the heat generated by the condensation process, that is called latent heat, it will be distributed larger area. When I distribute larger area, automatically the temperature will be less. When the temperature is less, cyclone will weaken. So that's why small vertical wind shear is necessary for intensification of cyclone. Pressure convergence up to 400. 400 means around 6.5 kilometer height. The wind should have the anti-clockwise movement. Otherwise, the rising of air will not be possible. That's why convergence means inward force of wind or air mass to the center. Large area, 10 days mean surface temperature should be greater than 26.5 degrees. But formation of low cyclone or from the low pressure, depression, deep depression cyclone, 26.5 degrees centigrade temperature is required. Then only it can support formation of low pressure. Then if it is 30-31 degree, automatically the intensification of low pressure or cyclone will be like severe cyclone, very severe cyclone, extremely severe cyclone, super cyclone. And presence of upper level divergence. When the air mass is coming inside, so that mechanism should be there. The air mass should be removed from there. That's why the upper atmosphere is going around 12 meter height, so it is removed from the atmosphere. That's why continuous air is coming and going up, and continuously divergence is there. So automatically the cyclone intensity will be maintained, and it will intensify more also. So these are the pictures actually. This is Amphan cyclone picture, how it is coming. So here also centrally, now due to technology development, now it is available. So you can see how the wind speed in the central, how much the wind speed like that, and what is the pressure value, how much the height like that, it is giving now. Due to technology development, earlier to 99 super cyclone, we are not able to say about these things. Now it is possible. So cyclone forecast is, you can say, more than 90% or 100% accuracy nowadays. These are Amphan cyclone track, because these are also provided by some UK network. So UK Met Office is also providing. This also helps to Indian meteorologists to predict the cyclone movement also and intensification also. So this is a track of a cyclone forecast, because now the technology development, these are available. So it becomes so easy for the forecaster to brief to the general public and government also about its trajectory, how it is moving and which direction. And it's giving dates also for probability of wind speed. It is also mentioned. So here also you can see the SST is increasing, pressure is decreasing. You see here 950, the SST was 27 degree. When SST was 29 degree, pressure was around 35 hectopascal. When pressure is 920, your temperature is around, you can say 31 degrees Celsius. 31 degrees Celsius, pressure 920. When pressure is so low, that means cyclone is severe or very severe, or you can say extremely severe cyclone. That means this is directly this sea surface temperature increases, pressure decreases. Inversely. Potential intensity theory simulate increase in intensity. Some of the so many methods are there because due to model or computer high speed availability of high speed computers and programs are available. So within 3 hours, it can give the prediction up to 10 days. So now it becomes easy for the meteorologist to predict the weather also and severe system, cyclone, thunderstorm like that. So this is an intense tropical cyclone, central location high. This is IWAL like that. The intense low pressure system form over warm ocean surface. Strong winds circulate anti-clockwise are centered in northern hemisphere. Central pressure fall by 5 to 6 HPA from surrounding and speed it reaches 34 knots. So for full grown cyclone, violent wind in atmosphere 100 to 1,000 km across, 10 km high, gale winds up 150 to 50 km per hour. These are the cyclone definitions. So if you see the tracks, this is you see in the month of this is a depression, cyclone storm, severe cyclone storm from 1990 to 2013 in the month of May. This is May. These are the tracks, and this is the June track. June in general cyclones are less, but maximum depressions, deep depression are formed. July also cyclones in general do not form. October it forms. This is October. October, so many cyclones have formed. It has crossed the coast, and after crossing coast, it's movements like that. And this is November. November also very few cyclones have crossed. This is December. No cyclones has crossed Odisha coast. December. So earlier I have told you about the energy, because the cyclone gets energy by the latent heat. That is the condensation process. So that's why tropical cyclone from when the energy released by condensation of moisture in rising air causes a positive feedback loop over warm oceans. If you see the central location, so the wind is coming from other sides and reaching at the center, and from the center it is going up. When it is going up, some also air mass also coming down. When air mass is going towards higher side or to top of the atmosphere side, so the temperature decreases with the height. When the air mass is coming down or subsidence is there, because there will be squeezing or contraction will be there, so temperature increases. That's why central location we have clear sky, because due to heating, whatever the water vapor present at the central location, it gets evaporated. So when evaporation is there too much, the water vapor is minimum available for causing rain, or that's why in the central location we have very clear fine weather there, because very less rain, low wind speed, and no very little sunshine also there. But if you move 50 kilometer or 60 kilometer away from there, we'll get high wall. So there is a high wind speed area. So there wind speed can increase 200 to 50 kilometer per hour. If any it touches the coast, storms or height may also increase. Very torrential rain also. But if you go away from there, this is called what we call your outer storm area. So that because wind speed will also increase and rainfall also will decrease, light to moderate rain will be there. Heavy rainfall will be in the high wall region. And main cause is that latent heat. So latent heat, that is by the condensation process, evaporation, condensation, then latent heat release. That latent heat supports the maintaining the intensification of cyclone, and further intensification also it supports. So sea surface temperature, low vertical wind shear, these are the intensification. Earlier also I am showed 968, 76. These are called intensification of cyclone by sea surface temperature, low vertical wind shear, strong outflow, strong convergence. These four factors support intensification. If these factors are supporting, then cyclone can, that means low pressure can intensify gradually up to super cyclone. So prediction of extreme, the program predicting how tropical cyclone frequency might respond to climate change can be broken into two parts. Predicting how the prevalence of necessary conditions will change, and predicting how the frequency and strength of potential triggers will change. Given increased concentration of greenhouse gases, theoretical considerations suggest that the strength of large-scale tropical circulations, such as monsoons and trade winds, will increase. That means when a greenhouse gases presence is high, the climate change will be there, global warming will happen. When global warming, the sea surface temperature will increase. That's why nowadays, whenever any low pressure forming, if it is intensifying to depression or deep depression, it supports further intensity cyclone and higher intensity, severe cyclone, very severe cyclone, like that. But during April, May, if you see the past data period to 2019, mostly it goes to cyclone or severe cyclone. Rarely it goes to the very severe cyclone. But from 2019, we have been experiencing mostly when the low pressure intensifying to cyclone, it is going to extremely severe cyclone or super cyclone, like Amphan and Phylline, Hudud, Titli, like so many cyclones have. So the central we are getting the blank. This is now available from the cloud side. So this blank is called the eye of the cyclone. Here also, this is circulation, this giving wind speed also, that the big triangle is equal 50 knot, 1 knot is 1.86 kilometer. This is around 120 kilometer per hour, 140 kilometer. It is going on giving. So it helps meteorologists to give the prediction or to give the forecast improvement. Yes, the pressure also it is showing. Here also the surface charts also available now. Digital charts also available. Here manually it was being prepared. This is cloud available, and this cloud picture, and this is Gopalpur radar, and that is a Fani cyclone. You can see this is the eye of the tropical cyclone Fani here, Gopalpur. This is also showing. So horizontal structure, I have already told you, I wall cloud outer storm area, I have a circular diameter 10 to 50 kilometer. eye surrounding 10 to 50 km thick eye wall. Then beyond 250 km, this is a outer storm area, because wall cloud region is the most dangerous portion. Eye also very calm, and this outer storm area also comparatively low wind speed and less rainfall. Only wall cloud region is the that is the location where we can anticipate very, very severe weather there. So there's a vertical structure. This is a horizontal structure I told you. Vertical also there are 3 layers: inflow layer, middle layer, outflow layer. Inflow layer, that is up to 3 km. That is the convergence. Wind is going anti-clockwise. Middle layer 3 to 7.6 km. Neither predominant inflow or outflow. So the wind blows in such a way anti-clockwise, clockwise, mixing is there. But outflow is there 7.6 km on top. That is only, that is divergence is there. Anti-cyclonic flow is there. That means in the cyclone, the lower part it is the cyclonic, that is anti-clockwise, and the upper part clockwise. So this is called outer storm, outer flow layer. This is inflow layer, and this is middle layer. Middle layer, this is mixing of anti-clockwise and clockwise. Because due to this what you call American countries, they have got the jet planes. When a cyclone form, they enter to the cyclone center and they have taken the pictures. And it's also cyclone also do not immediately intensify to cyclone. Initially low pressure, that's why it is divided into 4 parts: formative stage, immature stage, mature stage, and what you call your decay stage. Formative general low pressure, depression, deep depression. Then cyclone formation, immature stage. So immature stage, whatever the increase in intensity, it will support in immature stage. Eye wall, central pressure will decrease, intensification to severe cyclone, very severe immature stage. When mature stage comes, it maintains its immature stage and it doesn't change anything. But decay stage, when cyclone come closer to the coast or it crosses the coast, then cyclone will weaken. This is called decay stage. Or the wind shear is high, then cyclone also weaken in the bay itself or in the Arabian Sea, that is central water bodies also. This is a track of cyclone of your super cyclone, because super cyclone was stationary about 24 hours in Bhubaneswar, Cuttack, so devastation was high. So this is case of Phylline. This is case of Titli. This is Titli. This is Phani. This is cyclone Phani. This is Titli. And this is also Phani. And this is also Bulbul cyclone. These are the different cyclones, how it is forming, that I have explained. Impacts of tropical cyclone. So mainly now it is very reduced. 99 super cyclone, 9,500, 990, Gujarat coast cyclone 1,000. But 1963 East Pakistan, that was now in Bangladesh, 22,000 people died. And 1965, 17,000, because Bangladesh is the region where storm surge height increases 10 meter, 12 meter height. So due to what seawater inundation, so more people die there. There are 3 factors which cause damage to the cyclone adverse weather. That is the strong winds, heavy rainfall, storm surge. That is the strong winds means that is the high wall region will be there, very high wind speed will be there. So you can anticipate uprooting of trees, telephone, electric installations, poles, roofs, etc. And in heavy rainfall, in our super cyclone 30th October, 430 millimeter rain occurred in Bhubaneswar. So similarly, this is also one of the factors. You can anticipate flood also during the cyclone movement. And storm surge. Storm surge, that is inversely proportional to the depth of the sea. If depth of the sea is low, storm surge height will be more. If depth of the sea is high, storm surge height will be low. So if you move from Gopalpur to Baleswar, the sea depth is gradually decreasing. So that's why the storm surge height is increasing gradually from Gopalpur to Baleswar. Our Baleswar side will have around 10, 11 meter storm surge height, whereas 3-4 meter height in Gopalpur. That's why, and funny that our what we call your Phylline cyclone and Hudur cyclone. Phylline cyclone also didn't experience that much of rise of storm surge height, because the Gopalpur sea coast is not supporting increase of storm surge height. So here we can see that is this Baleswar 13.1, 13.7, 10.3, but the Gopalpur side it is around 3.8, 4.0 kilometer. This is the frequency of the cyclone disturbances. So my point is that now the intensity of cyclone has been increased. Earlier, the lower intensity cyclone forming, a cyclone or severe cyclone. Now, whatever the system is forming, it is intensifying to severe, very severe cyclone, extremely severe cyclone or super cyclone. So if you see the North Indian Ocean, the total cyclone storm over Indian Ocean, 89 to 10, the increasing tendency. But here it is, you can see the only cyclone storm, it is gradually decreasing. But if you see rainfall distribution, secondary max 2 degrees away from the primary maximum to right. That means the rainfall is increasing. These are the factors where the rain is more. So cyclone warning, IMD is giving pre-cyclone watch, cyclone alert, cyclone warning, post-landfall watch. 72 hours pre-cyclone was issued to Chief Secretary, that is issued by our Director General Meteorology by Delhi. Then cyclone alert is issued. Now the procedure to change because earlier we were issuing 3-4 times, but now every 3 hours the bulletins are issued. Cyclone alert, cyclone warning is issued 24 hours, and post-landfall when the cyclone has crossed the coast and gradually weakening in the land areas, so then we will issue the post-landfall outlook. Then finally, when the cyclone has weakened and there is no effect, then de-warning will be issued. These are the cyclone yellow, orange and red, different colors depending upon the intensity. And these are Doppler radars because this is Paradip, this is Simla. But earlier how IMD constructed the buildings, high-rise buildings, but now also the tower-based they have put at Simla. So now there are 13 countries in the Southeast Asia. So they have formed a panel so by WMO. Bangladesh, India, Iran, Maldives, Myanmar, Oman, Pakistan, Qatar, Saudi Arabia, Sri Lanka, Thailand, United Arab Emirates, Yemen. Though there are 13 countries, they have provided 13 names. It has been put in 13 columns. So if any cyclone forming in the Bay of Bengal, Arabian Sea, one by one, the name is provided or name is given because already predetermined. So these signals also port also that Paradip port, Gopalpur port, like Chandbali port, they are also issuing 1, 2, the day signal, night signal. We have got 11 signals. So 11 is the highest signal. When the port authorities do not get any information from meteorology department, they will hoist 11 number signal. That means cyclone intensity is high or severity is very high. So all the communications are disrupted. So they will issue the last signal 11. So warning also now I told you different now to Twitter, what we call WhatsApp, email, so many messages. Earlier only we are sending by fax, then it changed to SMS and email. Now also Facebook, Twitter, email, all modern facilities are available. So because you see before 1998-99, IMD could not able to predict because technology development was not there. So that's why 1,042 people died in heat wave. 1988 people died in cyclone because IMD could not pinpoint the forecast because before 99 we didn't have the Doppler radars and even communication facility was not there. Only telephone or telegram facility was there. That's why the communication data availability was not there. So that's why when the analysis could not make properly, so when analysis was not there, forecast also was not up to the mark. So that's why so many bad things or devastation occurred in 99 heat wave and in 99 super cyclone also. But it changed on 2013. So during 9 super cyclone, available adequate data from ships and ocean quays except one station up at Paradip. Analog CDR stopped recording 29th morning and its photograph feeling damaged. Windspeed recorder unserviceable. No vortex. No, at that time no model was there. Everything was manual. Now model based forecast. So model is also gradually improving. Now also it is giving good result about day-to-day weather also and even if severe weather, thunderstorm and cyclone also. Improvement in weather forecast management due to development of science and technology. Climate science has grown with the development in numerical weather prediction models and improvement in observation system in the last decade. Wind data across globe available. Ministry of Air Science modernized equipment and 3 weather satellites provided every 15 minutes. Kalpana, Unsha 3D, like that. Weather forecast now available in different time scales from short time to long-term climate. Multi-model ensemble technique provided forecast closer to actual observations. Speedy communication network supported transmission of early warning, nowcasting to local people. Now IMD also, we have Doppler radars, 37 automated weather station, 117 automated 28 manual observatories, rainfall data, 314 ranger stations. Farmers are advised to follow agricultural practices before disaster by OEOT. OSDMA also created 99 state, now has 87 multiple cyclone. Because my point is that now the death toll reduced and people awareness also increased. So earlier awareness was not up to the mark. Now people get electronic media due to electronic media, people get information directly instead of from IMD forecast. What are the precautions we have to take?
Excuse me, sir. Hello, sorry for interruption. Actually, our time for the session is over.
Okay,
So
okay.
we can conclude within 5 minutes.
Okay.
Okay.
So though cyclone has so many bad effects or devastation, but it has also good in case precipitation over wide areas including dry areas. Because our this is what we call KBK region, earlier it was not getting rain due to movement of a depression or cyclones like Titli, your Phylline, those areas are getting rain. So groundwater discharge also happening under the good also, and maintaining global heat balance also. Because we know that the equatorial region is more hot and polar region is cooler. That should be balanced between equatorial region to polar region. When cyclones are forming, you have marked, it is moving from towards north. From south, it is going towards north. That means the heat is transporting from equatorial region towards the tropics, what we call extratropical region, or this 30 degree, 60 degree north, or like that polar region. The heat is balanced. So global heat balance also maintained by cyclone. And due to churning of water, from a lower water coming up and down, up water going down, so it supports fish breeding also. Then if it is cyclone is coming in the month of May, June, like that, very strong heat, so people can feel cooling also due to the cyclone, because wind also there and rainfall will be there, so cooling will be there. These are the beneficial effects of cyclone. So these are the basic safety precautions to be taken, like radio, latest weather warnings, pay attention to community warning systems, do not listen or spread rumors, do not venture out near streams or rivers during cyclone, prepare an emergency kit containing a portable transistor, radio, a battery, torch, like that, so many things. Keep plastic sheets, plastic rope, rubber tubes, waterproof bags, etc. Store your food, grains, agricultural products in plastic bags safely. Check your house, repair doors and windows wherever necessary. Bolt glass windows and put shutters in place. Locate cyclone shelters and safe houses for taking shelter. These are the basic safety precautions. Conclusion, encourage use eco-friendly goods which may be costly now, but in the long run or economically, they avoid negative impacts to global warming. Because my purpose is that greenhouse gas emissions, you have to minimize it. So that's why you have to use the eco-friendly goods. That means a renewable source of energy, like wind energy, wave energy, solar energy, instead of thermal energy. Because thermal energy, we are getting electric by two processes, hydroelectric process and thermal electric process. Hydroelectric process, it doesn't have any impact to the climate or environment. But thermal electric, they are burning up fossil fuels, what we call coal or petroleum products are burning, and electric generation, NTPC, national thermal power, or that is thermal power. So greenhouse gas emission will be enough, plenty. So it will have effect to the climate. So global warming will be increased. So to avoid that, so eco-friendly goods, that's what it is. Cyclone characteristics change because all cyclones do not follow the same characteristics. It changes its characteristic time to time. So that's why you always follow the IMD bulletin, whatever they are giving. So accordingly, take the precautions. Self-preparedness for stock of dry food, valuable documents, road leading to cyclone shelter, emergencies center, police control room, mobile telephone number, radio for latest news, stock of candles. These things you have to make. And don't panic and exchange of information with you. Don't panic and exchange information with your neighbor. That means if you are getting information about the cyclone intensification and crossing the point coast, that you can tell your neighbor, so they can get the help. Thank you, sir. Questions, sir, because sorry for this problem.
Sir, one question can I ask?
Yes, sir.
Sir, as you saw in a graph, there are data available about total cyclonic disturbances.
Yes, sir.
Likewise, do you have any data place-wise, like for example, in Gopalpur, how many times cyclonic situation have been like that?
Available because now tracks are available 1891 to 2015 to 1819 available. So we can find out how many cyclones have crossed the Gopalpur, Paradip or Balesur, like that we can find out.
From where, sir? What is the source?
That is the one from IMD only.
Okay, okay.
Because IMD is maintaining a atlas. That is the archive they have made. All the cyclones across the Indian coast, either east coast or west coast. So they have the cyclone atlas from 1891 to every year they are modifying it. So from there you can get.
Just personally, I wanted to get. I am from a coastal village of Balesur.
Balesur.
So I wanted to know at my place since so many.
Available. Either you contact me afterwards, or you can contact IMD also. If you officially want, you can write letter to IMD director. They can provide.
No, sir, not official. Just curiosity point. Okay, sir. Thank you so much.
Okay, sir. Then thank you for your nice presentation. And so, on behalf of the organizing committee, I would like to thank you that you have agreed to our proposal for being a research person for this refresher program. So now I would request the participants to join the next session. The link is already there in the WhatsApp group, and I once again thank the speaker.
Thank you, sir. Thank you to
for
all.
his
Thank you
excellent.
to all for patient hearing, sir.
Then thank you. So now we will switch over.